Hello everyone, this video is going to cover the 6L80, 6L90 overhaul. We're going to go through the transmission from front to rear, going to go over the oil pump, the gear set, all the clutches. We're going to go through the valve body, every valve. We're even going to put a TransGo shift kit in it. We're going to look at the oil pump modifications and the valve body modifications. So let's jump right on in. This is an overhaul video for the GM 6L80, and we're going to go through and take this apart, inspect the pieces and parts, look at some of the areas that can commonly fail in these transmissions, and then put it back together, see what all is involved. First, let's take a look at what we've got here. This is the pump / bell housing assembly that we'll actually remove here in a few. Rotate this around. We have a vent up on top, nothing too exciting there. This was a four-wheel drive unit, you could tell by the short output shaft, and a transfer case would bolt up to this area right here. And then here's our oil pan assembly. Kind of rusty, dented. Pretty sure I'd change that if I were to rebuild this for a vehicle that's on the road. On the side here, we have a connection for our oil cooler fittings. And if we swing around to the other side of the transmission, this is the code designation. This is an 8 CKA. I know we're reading this upside down, but 8 would be the model year of the transmission, and CKA would be the model. So if you were to compare the CKA is going to reference the different vehicles that this might go into. And we also have a line pressure fitting right here. So in the vehicle, we can hook up a line pressure gauge to it and control the pressures to see if the pressures are achieving what we need to achieve. Let's start by pulling the oil pan off. This 6L80 is probably one of the most common transmissions on the road. It's found in pretty much every 2008 to newer Chevy truck, everything from like a Corvette to a Camaro, rear-wheel drive applications. It's actually a pretty easy transmission to overhaul. You don't need that many special tools to take it apart. In fact, one of the most useful tools is this monstrous snap ring pliers that they've got. Adaptacase makes it. It makes it real easy to take apart this massive snap ring they got in there. It can be done without it. Before we got that tool, we had to use a bunch of big screwdrivers in there and finagle it out. Seems kind of sketchy, but it worked. We're going to go ahead and take this thing completely apart. We're going to go through and do all the inspections and the measurements, and we're going to look at what typically happens in an overhaul. We're also going to go through and modify this valve body with the TransGo shift kit, and we'll take a look to see what are the things that they are doing when they add some of these valves into this valve body. What are they correcting and how are they correcting it? So we'll go through this, and this will likely be more thoroughly explained in a companion video, but during this video we're going to go through the process of installing it and see what's all involved. And so we're going to go ahead and start tearing into this thing. We've already got the oil pan off, and the next step is going to be to remove the valve body assembly. When we go to pull the valve body out, the only bolts we need to worry about initially are these bolts that I painted some blue paint on the end of it. And in this transmission, they're kind of those inverted Torx type bolts, so they're pretty easy to identify. One of the things we need to do before we pull this valve body out though is lift up on this little white lever here, and that's going to allow you to pull this pass-through connector. That lets you pull that pass-through connector that exists between the Tecum and the external part of the case. Obviously, if you took the bolts out and you didn't have this out, that would hang you up. So you got to get this out first. Just lift up on that lever. At this point, we could just lift the valve body with the Tecum completely off. There's no wires to disconnect or anything. So we'll go through this transmission and we'll save this assembly for last. Now that we've got the valve body off, we could take this bridge seal assembly out. This bridge seal is going to allow for the connection between the valve body and the center support section. The center support section will deliver fluid pressure to our 2.6 and our low reverse clutch. Next we'll take the bell housing off, and when we take the bell housing off, it's going to take the oil pump out with it. So now we've removed this bell housing that also includes the pump assembly. When we pull these bolts out, we'll be able to separate the pump halves and inspect the pump. We'll do that in a little bit. This is an area that often has issues in these transmissions. Basically what happens is the torque converter in these transmissions fail, and the metal from the torque converter passes through this oil pump and it gouges up the oil pump. So it's very common that when you do an overhaul on these things, you'll find an oil pump that's destroyed. Now there's a couple options. Some people go through and they machine the pocket and the pump surfaces to restore it, and some people just go out and buy a new bell housing and pump assembly. So I'm going to go ahead and pull the input shaft out. With the input shaft is going to come the 456 clutch, it's going to come the 35R clutch, the 1234 clutch. I'm going to be pulling out a lot of stuff with this. It's kind of heavy. Next I'm going to go ahead and pull some of these drums out. This is a 456 clutch hub assembly. This is the 1234 hub assembly. And this is my 35R hub assembly. At this point in the transmission, I've got to pull this huge snap ring out that lives on the inside of here. This is the snap ring where I use this massive set of snap ring pliers to get out. So I can go in there, grab onto the snap ring. And it's still a hard, even with this massive pair of snap ring pliers, it still requires a bit of strength to get out. They don't want that thing going anywhere. Big mamma jamma. Now I can go ahead and pull the center support out that contains my 2/6 clutches and my low reverse. That's what that snap ring was retaining in there. Next I need to pull this gear set assembly out. There's a lot of weight involved with this one. So I'm going to go ahead and turn this transmission fixture on its side. And basically not fight gravity too much in trying to get this out. As you can see, it doesn't take much to completely disassemble this, but now we got all the sub-assemblies. We need to take the oil pump apart, we need to take this gear set a little bit further apart and inspect it. We've got our clutch assemblies and our pistons that we need to go through and look at. But at this point, we've got the case pretty much cleared out. This is an interesting transmission. Those students in my class that went through that 6T70, 6F50, you're going to notice that the clutches are labeled the same on this transmission. They have a 1234, a 456, a 35R, a 2/6, and a low reverse clutch, and they also have a low roller. In this case, it's a low sprag, not a low ratchet or anything like that, so they have a low one-way clutch. So you might assume that this is going to be the exact same power flow and layout, but this is a completely different transmission. If you also remember on the 6F50 and the 6T70, the middle gear set had a sun gear that was splined to the input shaft all the time, so it was always input. They don't do that here. They do something similar. In this case, they're holding a sun gear on the front gear set. But you're going to see that this is a completely different gear set, completely different power flow. This is actually called a Lepeltier gear train. And this Lepeltier gear train has a Ravenel gear set in the back. We'll take a look at that when we take this apart. So this is a completely different power flow than the 6T70, 6F50, even though the clutch designations are the same. And actually, what's holding and what's driving is different. If you remember, on the 6T70, the 1234 clutch was a holding clutch. Well, these are our driving clutches on the 6L80. We have a 1234, which drives onto this shell right here, that actually goes back and grabs the rear sun gear. And we've got a 35R clutch, that's a driving clutch, and it goes in and grabs onto this shell, and that shell is going to drive the front sun gear of this rear gear set. And then the 456 clutch is a driving clutch, and it's going to go all the way to the back and it's going to drive the carrier on this Ravenel gear set. We also have a 2/6 clutch, a holding clutch. So we have two holding clutches in this transmission, and we have a one-way clutch. So the two holding clutches that we have a 2/6 clutch that's going to grab onto this drum, and that's going to hold that front sun gear. And we have a low reverse clutch assembly that's going to hold on to that rear carrier assembly. It's actually lugged into it. Matter of fact, this assembly right here that I've got kind of dangling out there, that is the sprag assembly, and it splines, it lugs to the carrier. So we're going to see all these connections here in a minute. I just want to go through and show you the hubs that we've got inside this transmission, the drums, the clutch assembly, the drum that drives these different hubs, and to mention that this gear set's not the same, even though the clutches are the same. So looking at this very first gear set, we actually have a gear set that works up front. Here's another interesting fact on this transmission. This transmission doesn't use direct drive. Most rear-wheel drive transmissions, we can think of the fact that if they drive two parts, you're going to have direct drive because this whole gear set is going to spin as an assembly. That's actually not the case on this transmission. The way this is set up is the input shaft is going to drive this housing, and in this housing is a front internal gear assembly. So the internal gear assembly is always going to receive input on this gear set, on the front gear set. So the front gear set, the internal gear is always input, and if you take a look, the sun gear, I get it on there, is always splined to that stator support. So my carrier is always going to be output. So I have a gear set right here in the front of this unit that is always going to work in an underdrive with the medium-sized gear driving a large gear. So right off the bat, I've got an underdrive. And then this housing assembly, when these clutches, the 1, 2, 3, 4, or the 3, 5R clutch is applied, they're going to deliver torque to the rear gear set with this gear reduction. And this gear reduction is about a 1.5 to 1. So that rear gear set is always going to see a gear reduction so long as its input is coming from the 1, 2, 3, 4 or the 3, 5R clutch assembly. Otherwise, they can deliver torque to the rear gear set through this clutch assembly that's located on the back of the input drum, which is called the 4, 5, 6 clutch assembly. The 4, 5, 6 clutch assembly can deliver torque to that rear carrier. So directly from my input shaft to that rear carrier, I can deliver torque through this 4, 5, 6 clutch assembly. Man, these parts are sharp, cutting me up. Ow, just did it again, I think. So to reiterate, we've got this input shaft coming in. It's with the 4, 5, 6 clutch applied, it'd have the ability to drive the rear planetary gear set, Ravenel gear set, and the front planetary gear set is always being operated. The internal gear is always input, the sun gear is always held, so any output coming from this carrier assembly is going to be at a gear reduction, about a 1.5 to 1 gear reduction, because that planetary carrier splines into this housing. So this housing is always going to spin at a 1.5 to 1 gear reduction. And as long as that 1, 2, 3, 4 clutch is applied, we know through this hub, we're going to be able to deliver torque to that rear sun gear. And as long as the 3, 5R clutch is applied, we know we're going to be able to go through and deliver torque to that front sun gear. So those are our 3 driving clutches: 4, 5, 6, 3, 5R, 1, 2, 3, 4. Now as far as holding clutches are concerned, I've got the low reverse assembly and I also have a 2/6. And so long as that 2/6 clutch is applied, the same shell that drives that front sun gear, that drives it from the 3, 5R clutch, is now going to be able to hold it. So obviously you can imagine you can't drive and hold at the same time, so 3, 5, and R is for driving, 2 and 6 is for holding. And that's going to go reach through that center support and grab onto this front sun gear assembly. The other holding clutch is the low reverse. Now low reverse has the ability of grabbing onto this carrier assembly and holding it. So does the low sprag assembly. The low sprag obviously is only going to be able to hold it in one direction and not the other. Freewheels in one direction, freewheels in clockwise direction, and holds in the counterclockwise direction. So the way that works is that if you take a look at this housing has a set of splines around this inside diameter here. It's lugged to the case on the outside, and the housing has these thick set of splines on the inside. So when that roller clutch gets placed in there, the inner race of that is connected to that set of splines. And that carrier itself, it has a set of splines that lug in with these large splines that we have on the one-way clutch, on the outer race. So if I apply the low reverse clutch, which is also splined to the outer race of the sprag, I'll stop this from spinning in either direction. If I have the low reverse clutch released, this will always be allowed to spin clockwise as viewed from the front, but it'll hold in the counterclockwise direction as viewed from the front. I'm looking at it from the rear right now, so it's the opposite. The front of the transmission would be coming up that way. But so basically from this side, it's going to hold when I turn it clockwise, and it's going to freewheel counterclockwise. So let's go ahead and take a look at this gear set while we're here. The front gear set's pretty simple. It's just a simple planetary gear set. Sun gear held, internal gear input, carrier output, always working in a gear reduction, a minimum gear reduction with a medium-sized gear driving a large gear. This gear set's pretty interesting. They actually do have a couple other units that use a gear set like this. Like I mentioned earlier, this is called a Lepeltier gear set because they have this simple planetary gear set feeding this rear Ravenel gear set. What makes a Ravenel gear set a Ravenel gear set is that I've got this single internal gear assembly. It basically spans from one end to the other, and it is the output component. The rear internal gear assembly on this Ravenel gear set is the output of this transmission. And on my planetary carrier, it's built a little different than what we're used to seeing. What I have is a large sun gear and a smaller sun gear. The large sun gear is placed here towards the front of the unit of the gear set, and it rides up against this planet, and then that planet rides up against its internal gear assembly. And then there's a smaller rear sun gear, and it rides up against a planet, which rides up against another planet, and then rides up against the internal gear. So it's kind of like having an idler gear assembly. So we have two separate sun gears in this. The smaller gear in the back drives a planetary pinion, which drives a planetary pinion, which drives the internal gear, and then the larger one up front is going to drive a planetary pinion and drive the internal gear. So really that front gear set is like the typical gear set that we look at on any old transmission. And that rear half of that gear set has got that extra pinion gear in there, or planet gear, and it works like an idler gear. So, but what makes it a Ravenel is I've got the two sun gears, I've got this common carrier that holds all these, both the front and rear planetary gear set, and I have a common internal gear. So this was an issue that a student brought to my attention. He was taking this apart, and this thing's already been apart before at that time, and the planetary gear set would not come out, which isn't too surprising, but the snap ring that was holding this internal gear in was really difficult to get out. So we realized that whoever put it together last actually had the gearing upside down. There's this step right here, and that step is designed to go down. It covers up the snap ring for the bottom internal gear. And if you're struggling to figure out if that's the reason why it goes or the way it goes, you can actually see on this gear at least, they've got these little dimples towards the top of the gear, and if you look in the actual drum, you can actually see where those dimples are kind of casted into this drum assembly. So there's a matching set of dimples on the drum and a matching set of dimples on the gear. I don't know if those dimples really serve a purpose. Even if service information didn't do a good job telling us, which it does by the way, it says that the step side goes down when you're assembling it, but the service information didn't do a good job, you can actually match that up by looking at these, the dimples on the housing and the dimples, which I'm going to call them those dimples, I don't know really what the best term for that, and the dimples on this internal gear. They're both facing up. So this gear was in upside down and made it real difficult to get that snap ring out. And they do that also on this bottom internal gear. But the bottom internal gear is idiot-proof. You cannot install it upside down. You'd have to leave parts out in order to get that in upside down. Come on now. There's a spacer and this bottom internal gear, and you can see they've got those little dimples all the way around on the bottom internal gear, and those also have little dimples on the housing, which I know you probably can't see very well, but the big thing with this internal gear assembly, this bottom internal gear, is there's a chamfer right here. And if you tried to install this upside down, it would cover up the snap ring groove. You wouldn't be able to get this down far enough. So Like I said, this is kind of idiot proof on how it goes back together. The bottom one, it'll only fit one way. These two snap rings that hold these internal gears in, they're the same thickness, same outside diameter, same design. So you really can't get those mixed up. Now, if you didn't want to pay attention on how to line these two gears up, you could slide the internal gear onto the carrier and drop this whole assembly in and then put your snap ring in. Or you could make sure that the teeth line up just by kind of looking in there. As long as these teeth kind of line up on the same plane, you can put your snap ring in. And you can see now there's a little bit of looseness here, but at least you can get the snap ring out if you ever had to. So in order to get this gear set apart, we actually have to take this little bearing assembly out. And that bearing is pressed in there, so in order to get that out, we're going to have to kind of slide hammer that bearing out, and then we can take the rest of this planetary gear set apart. So now that we got the needle bearing out, we can disassemble this gear set to inspect it a little closer. That's that front sun gear assembly that we talked about. Notice how these splines are offset, so you don't want to get that flipped upside down because the splines are designed to run a little deeper in there. Then we've got our rear gear set. Same thing, the splines aren't all the way through, so you don't want to install that upside down. Here you can see that smaller sun gear, it's going to mesh with that inside set of pinions, it's going to mesh with their outside set of pinions, and then they're going to mesh with that common internal gear, where that large sun gear is going to mesh with that single set of pinions that's going to mesh with our internal gear assembly. That is the Ravenel gear set. That's the concept of how it's designed. Now, if you also remember, just to kind of reiterate, my 456 clutch has the ability of driving this, and my low sprag has the ability of holding that carrier assembly, holding it in the counterclockwise direction, letting it freewheel in the clockwise direction as viewed from the front. And through this sprag assembly, the low reverse clutch can lock this carrier assembly from spinning in either direction. And just as a reminder, that rear sun gear is also going to be able to be driven by the 1, 2, 3, 4 clutch assembly. And that front sun gear is going to be able to be driven by the 3.5R or held by the 2.6. So these 5 clutch assemblies and 1 sprag assembly, they got a lot to do in this transmission, don't they? All right, with the planetary gear set together, I'll just load it back in there. Watch fingers. Okay, to clear up a little bit of space on this bench, we're going to go ahead and just install this gear set, kind of get it out of the way. Now I could tilt the transmission like I did when I removed it and kind of insert it the same way. But there's also a tool that you can make. This right here is a 12 millimeter by 1.75 millimeter thread. They sell that tool also, but it's pretty easy to make if you've got a bolt stash laying around. And you could just kind of thread that in there. And it gives you like a handle, something to lift this whole gear set up by. So you want to put your Torrington bearing down. On the inside of there is a pocket, a machine pocket kind of designed to fit around this race, this outer race. So you want to make sure you have the outer race. I call this the outer race because it wraps up around the outside there. So you want to make sure this lays down in that pocket, kind of centers itself with that outer race down. And then we can go ahead and lift our gear set and just drop it on in there. So it's kind of handy to have that tool. Makes it easy to pick it up. And like I said, you can make one pretty easy. Just find a bolt that has it's a 12 millimeter bolt that has a 1.75 millimeter thread pitch. And I just welded it to a couple pieces of tubing that I had laying around, and now I got a handle. So I'm going to go through and look at these parts as I assemble them. Naturally, that wouldn't be the most efficient way to do things. Most efficient way to do things when you're rebuilding a transmission is to take everything out, take everything apart, inspect everything so you can figure out what's good and bad, and then you can get your little parts list together or figure out what you can recondition or what you have to purchase new get all your parts in, and then assemble it. But for simplicity and to keep things kind of cleared on the bench somewhat, and to kind of go through things one at a time, as I need to put them in, we're going to first take them apart, look at them, go through the ins and outs. Want to put them back together, we're just going to go ahead and put them in the transmission. So now that that gear set is in, I am going to move my attention over to the center support assembly. And in the center support assembly, we've got our low reverse clutch assembly and our low sprag. And on the other side, we have the 2/6 clutch assembly. So I'll pull the 2/6 clutch assembly out because it's very simple. There's not much to this. In the service information, they talk about the snap ring openings. They want these snap ring openings to be at the 3 o'clock or 9 o'clock position. So we can go ahead and pull all these clutches out. You can see I've got a backing plate, and I've got 5 frictions and 5 steel plates, and I've got 1 wave plate. So that makes up my 2/6 clutch pack. There is a snap ring in here that holds this diaphragm spring in place. And I'll go ahead and pop it out. There is some tension on the spring, and there is a special tool to compress it. You guys know me, I don't like to buy special tools if I can make them. So I've got a homemade version of this. Something very similar to what we used on the 6T70, 6F50. But the only tool we needed on that transmission. Because some of these tools are hundreds of dollars, and I don't know. So here's a snap ring for it. This retains this diaphragm spring down. And like I did say, there is a little bit of tension involved in this. So it's without using something to compress these fingers down when you go back together, it'd be difficult to get that snap ring in. I'm sure it's not impossible, but it'd be difficult. And you might have to blow air into this through that one of those passageways to pop the piston out, but if not, the piston just comes right out pretty easy. Typically this would be replaced on an overhaul. Of course, this is a lab unit, so we're just going to go back together with it. You don't need any seal installers to seal this. The drum itself has a chamfer cut on the outside edge and a chamfer cut on the inside edge, so that'll guide those lip seals in. You know, you want to lubricate them and put some TransGel or some of that Dory's slippery stick, something like that on there, but it goes together pretty quick and easy. So just for the sake of science, we're just going to go through and put this thing back together, and I'm going to show you the little homemade special tool. This is the 3.5R ring that would normally live in the 3.5R/1234 clutch housing, and I've got extras of these, so I welded some steel plates to them. That way I can have something to push down on. And basically what it's going to do is those little fingers are going to, these little fingers manage to sit right on those diaphragm fingers. And ideally they'd be on the outside of the piston, but they're just on the inside of the piston, but it still works fine. Well, you know, I can press this down with my little screw press and get the snap ring in, no problem. There is a trick to it though. You want to make sure that this diaphragm spring is centered, because when you compress the spring, it actually has to fit down kind of over that snap ring groove a little bit. And if it doesn't fit down over that snap ring groove, you'll be tightening that little spring compressor and trying to compress this down, but the edge of this diaphragm spring is kind of just catching on that edge and it won't get past it. So when I use that little spring compressor to push this down, I'm going to eyeball this all the way around and make sure that it's not shifted to one side or the other. Here I've got my little screw press on the tabletop, and I'm going to take my special tool, part number, I made it myself, and I'm going to peek down inside here, and I'm going to make sure that this diaphragm spring is as centered as I can get it. If it's offset to one side, like I said, it's likely going to catch. And this would happen if you had the special tool, the actual expensive one that you buy, or if you just have your little homemade one. So you know, that's pretty much going to be the same deal regardless. Got to have that centered. This is really doing the exact same thing. I'm just using a part. By the way, if you don't have that 3.5R apply ring, you can buy one. They're only like $7 or $8 from the dealer. I don't know what it'd be from TransStar or from, you know, a supplier, but even the dealer, it's super cheap. So instead of buying the real deal, I'd probably still go out and buy just this 3/5R ply ring, modify it. Most shops are going to have a welder, so going through and welding onto pieces and all that kind of stuff isn't a big deal. All right, and that snap ring fell right in there like a dream. Even nightmares can be dreams though. So right here, this is like a $7 homemade tool, even if you didn't have anything. I assume most shops are gonna have a lot of steel plates laying around, and this piece right here, if you didn't even have it, you could buy it at the dealer for $7 or $8. Cheap. Much cheaper than the $200 that you would spend on the other factory tool. So this 2/6 clutch assembly is not adjustable. It does not have any clutch adjustments. That top snap ring, we want to put it between the, I'll spin this around, so that way the bottom is aiming towards me, right there. So I want to put it either at the 9 o'clock or the 3 o'clock position. I'm going to put it at 9, it's getting late. So we'll still check the end play on it just to see what we've got. In a lot of cases in the service manual, you're going to see they put a weight on top of these things. The weight they call for is a 10-pound weight. So really what I would do is just push down a little bit and see how far it goes down. And you're just basically compressing that top wave plate that exists. In this case, it's taking away about 5 thousandths. Now when I lift it up, looks like I'm going from 60 to almost 50, so I got about 80 thousandths of clutch pack clearance. Most of the clutch pack clearance checks that are adjustable are between 50 and 80 thousandths. So this is on the high end, but it's not adjustable, so it's not really much we can do about that. And I am reusing some components here, so maybe if I had fresh steels and fresh frictions in there and a new wave plate, it might be perfectly within spec. So I was just checking it so that way we can see what we've got, to make sure it's something that at least makes sense. If we were like 20 thousandths or 120 thousandths, then I know something's definitely not right. Now that I got this flipped over, we're going to go ahead and look at the low reverse clutch assembly. This one is adjustable, and you adjust it by changing the thickness of the snap ring if you need to. Now this is the one-way clutch, and you can see it's viewed from this side, which is the rear. It's freewheeling in the counterclockwise direction and locking in the clockwise direction. If you look right here, and I know you can't see that, but I'll try to include a picture. Even in the picture, it doesn't show up very well. It says, do not push here. So we have to get this snap ring out that's retaining this sprag assembly. And there's a little bit of a spring tension on it. The diaphragm spring that keeps the low reverse piston returned is actually kind of leveraging off the bottom of the inner race of this. So I've got to push this down to kind of release some of that load and get that snap ring out. So I'll use my screw press, and then I'm going to go ahead and use this plate that basically pushes on this washer area, if you will, of this. I don't know if that's real ideal. Now it's interesting, in the service manual they show their tool actually does contact the outer race. So I don't know who to believe. If you've got the service manual saying contact that, and then you say, see this little race says do not push here. I'm so confused. But regardless, it doesn't take that much tension to push down on it. You just push down a little bit, get the snap ring out. You don't want to get carried away, because this is kind of like a thrust washer that is like the end piece that goes between the sprag assembly itself and then these two, then the snap ring that retains it. So, and as I mentioned, we don't want to get too carried away with this. We're just going to tighten it enough to release the tension. That was like a quarter of a turn, and that was enough to release the tension on this snap ring. That was easy. Okay, this is the snap ring that retains it. Interesting, this was in a different spot, but in the service information, they talk about making sure that this snap ring opening is in the blind spot area. And I'll show you that in a second here. How are you supposed to see it if it's in the blind spot, right? Anyway. So there's a spot right here that has a missing spline. You might be able to see that right there. That actually makes it so that the race can only slide on in one spot, but they also want your snap ring opening in that spot. Once again, I don't really know why that would make a difference, But the reason why it was under a little bit of tension is because the bottom of this race, this inner race, was kind of pushing on that diaphragm spring right here. So you can see the bottom of that race was pushing on this diaphragm spring. So it's kind of serves two purposes. Allows for the retaining this inner diaphragm spring, and which kind of eliminates the need for another snap ring group. How about that? So this is a kind of a dual piston assembly. We've got the inner seal right here, lip seal, and then there's another lip seal in the middle, and then there's a lip seal on the outer edge. They do that because two of these passages will apply the low reverse. Because in a hydraulic schematic, you're going to see there's a separate passage for low and a separate passage for reverse. When we go back together with this, assuming we just got new pistons and all that good stuff, you can see that we have a chamfer in the housing. There's a chamfer that's going to guide this outer seal down in. There's a chamfer that's going to guide this middle seal. And then there's a chamfer that's going to guide this inner seal in. Also note that we have this big fat mamma jamma. I don't know if we're allowed to say fat anymore. This robust or hefty O-ring that goes in there that pretty much sits just under these splines. So we would clean all that good stuff out, make sure everything's clean, got the new seals, new pistons in there, lube up the pistons, put them in without doing too much damage. Number one rule, don't damage anything. Before we completely assemble this, I'm going to go ahead and lay this back in there, but before we completely assemble this, let's take apart our sprag assembly and inspect it. You would want to do this, obviously, if you're rebuilding a transmission and it's, a lot of metal gets passed through it. You want to go through and make sure that the sprag, if you're reusing the sprag, you want to clean everything out. So there's my thrust washer for the sprag. Here's my inner sprag race. When you inspect the sprag race, you obviously want to look for scoring. And then if they're grabbing really hard, they create this Bernelling, these kind of railroad track kind of look marks to them. This is in great shape. This is the sprag itself. Little figure 8 shaped elements. They lay over to allow the parts to rotate in one direction, and then when you try to go in the other direction, they stand up and then pinch between the inner race and the outer race. It's always kind of remarkable to me that these two shiny, smooth surfaces that we have right here, that they have the ability to lock together when another shiny metal piece gets wedged in there. I always think that's pretty remarkable. You can accidentally install this upside down, so you want to make sure it's facing the right direction when you install it. So everything is facing towards me right now, and I'm looking at it from the back of the transmission. So you want to be able to freewheel in the counterclockwise direction and lock in the clockwise direction, because viewed from the front, it's going to freewheel in the clockwise direction and lock in the counterclockwise. The way I always remember that is I think most of these transmissions, now this one doesn't have direct drive, but if any one-way roller clutch that holds the gear set part to the case, it's going to have to be able to freewheel in direct drive in that clockwise direction. Now, like I said, this doesn't have direct drive because of the way this gear set's configured out with the planetary gear set in the front and the Ravenel gear set in the back. Okay, now I got my roller clutch reassembled. Definitely want to double check rotations. Viewed from the front, it's going to freewheel clockwise, hold counterclockwise. And because if you get it backwards, it wouldn't be good. You would go to take off in first gear and it would freewheel and you wouldn't go anywhere. And if you maybe try to start out in default, it would lock up, it would bind up. Now we can reinstall our sprag assembly back into the center support. Now we do have to look, there is a set of splines right here. Those splines, we're missing a set of splines there, and we have to match that up with the section of the center support that's also missing the splines. We drop that in, and if you remember, that is where they want us to put the opening of the snap ring when we put the snap ring on. We go back to our press. Just going to go in as far as I need to. There we go. Snap ring is installed. Now that we got the sprag installed, let's go ahead and install our low reverse clutch. We have 5 frictions, 5 steels, and a wave plate. We'll start with our wave, build it up. Wave, steel, friction, and then alternate steel and friction. Remember that this snap ring is the adjustable one, and the one that we're putting in is 85 thousandths of an inch thick. So we're supposed to install the snap ring between the 3 o'clock and 9 o'clock position. This is the bottom of the transmission right here. So I'll go ahead and put it at 3 o'clock. No, actually I'll do it 9 o'clock. Be a night owl. Or is it AM or PM? Didn't say that in the service manual. Now we got to go through and check our clearance. This is the adjustable one. The clearance is supposed to be pretty much between like 50 and 80 thousandths of an inch. And they do have that 10-pound weight they want you to put on things to kind of compress that wave just a little bit or take up some irregularities. But I found that usually just adds about 5 thousandths to the clearance. It's going from about 30, 35 to 95. So we're right about 60 thousandths. So that's perfectly within the 50 to 80 thousandths. So this snap ring that's in there is the proper size snap ring. While I'm here, I'm going to go ahead and air check everything. The 2.6 clutch right here, put air into it. You hear a little leak, but it's because there is an air bleed. I have to put my finger over this air bleed that they have at the 12 o'clock position there, in which case it's a pretty tight seal. The low reverse, there's also those air bleeds back there. Ooh, excuse me. And then this one here. Remember, this piston has kind of 2 parts to it, 2 different surface areas. There's 3 pistons, and that one seal in the middle is a lip seal, so it has a tendency of squeaking over into the other circuit. At this point, we can go ahead and drop the center support in, clear up a little bit of room on our bench, and we'll move on to the 1, 2, 3, 4, and 3, 5R housing assembly. And before we drop this in for good, we want to make sure we have our Torrington bearings in there, so that way they are keeping these parts separated like they should. I'm going to go ahead up and line up these holes towards the 6 o'clock position, towards the pan, and then I'll look at these lugs when I drop these in. Should drop right on in there. Oh, there we go. If I can't see the snap ring groove, I might have to spin the output shaft a little bit, get that carrier assembly to line up to that sprag assembly, those lugs. There we go. And now we got to drop our big old spring in there. This is that one, we use that nice tool from Adapticase. These huge snap ring pliers. Definitely want to wear safety glasses when you do this. And try not to punch yourself in the face, give yourself a black eye if things slip. There's a taper on that snap ring. You want to make sure that taper fits up. This tool makes it a lot easier. And then we'll put our Torrington bearing on top so we won't forget it. Since I'm at that point, I can go ahead and install some of these hubs. I'll go ahead and put this 2.6 hub in there. There we go. That's all the way down. That was easy. Next, I'll install my 1, 2, 3, 4 hub. All right, got those in place. I got my Torrington bearing that I'll place in there. Let's move on to this 456 clutch housing assembly and also this 456 drive shaft that they've got here. This actually looks like it might have a clutch in it in itself, but it actually doesn't. This is a device that kind of minimizes vibration. So when you pull it apart, you actually see this like counterweight, and it has these friction discs in there. So this can actually slip in there. There's nothing grabbing, nothing driving. It's just kind of pinched in between there. And it's really there just to kind of absorb some of these torsional vibrations. So if you inspect that and it all looks good, you could just put it right back together, clean it out and put it back together. This does have a wavy snap ring to it, so you gotta make sure that you get it in the snap ring groove all the way around. There we go. So I'm just gonna go ahead and put this in the transmission, kind of get it out of the way. Now I'll go ahead and pull my 456 clutch assembly apart. You see we got 6 frictions, 6 steels, and a wave plate, and of course a backing plate. We'll go back to the screw press. We got a compensator piston or a balance piston, whatever you call it. That is retaining the spring assembly in there. So we'll push down on it and get this retaining ring out of there. Got the retaining ring out. And we'll gingerly remove the piston. So here are our 2 pistons. This is the actual 456 piston that applies the clutch. This piston right here is a balance piston or a compensator piston. And they keep this side of the circuit filled with fluid when this clutch isn't applied. And the reason why is if we still have residual fluid in the clutch, even when it's not applied, with this drum spinning at input shaft speed, that it's going to potentially create a centrifugal force and drift that piston over and drag the clutches on. But if we fill this side up with fluid and it's trapped in there, it's going to equal out. You're going to have the same amount of force working on both sides of the piston, and it won't drift over, and we'll rely on our return spring to keep that piston returned back into its home position. So you'll see this in a lot of transmissions. It's not uncommon, but that's the reason why we have 2 separate pistons in this 456 clutch housing. Things you'll want to inspect: you do have bushings in there, and that bushing is going to center itself on that 456 shaft, so you got to make sure that looks good and it feels good. There's also a Torrington bearing right there. We got to make sure that's in good shape as well. Typically we would put new pistons in there and obviously change the frictions out for sure, and then inspect the steels, and if the steels are bad, change those out as well. Now that we got all these parts cleaned up, we can go in and inspect everything real well. Of course, like I said earlier, you want to check that bushing. And these Teflon seals, some builders will change them. If they look good, a lot of builders will just leave them. They're single piece seals, so there's a tool that allows you to slide it over it, fall into the groove, and then there's a sizer. If you don't have that sizer, some people will put those on there. They'll squeeze them in with their hands, and then they'll wrap something around it to kind of pinch it in there. It could be wrapped around with some electrical tape and some hose clamp, maybe a zip tie or something, but you want to shrink them down, because when you go to install the oil pump, and that oil pump assembly and bell housing assembly, if it goes down, if it catches on one of those and tears it, you really have no way of knowing until the transmission fails on your test drive. So anyway, let's go ahead and put this back together. This is that 456 apply piston. We got an inner seal and an outer seal. There is a chamfer in this drum assembly to allow this piston to fall in. You want to just work it side to side, and it'll fall right in. Now, before we put this compensator piston in, we're going to want to put our diaphragm type spring in there. You can actually see the contact points where that diaphragm spring was contacting that piston. If this wear seems excessive, it'd be a good idea to change this out. We'll gingerly install this compensator piston here. Get in there. Try to be gentle with it, because the outside seal on that compensator piston will kind of guide itself into that 456 clutch piston. But the inside diameter seal's got to kind of go across the snap ring groove. So we want to make sure that we don't tear that inner seal up. And just remember that this compensator piston that we're installing right now, it isn't a piston that applies a clutch. It's a piston really that keeps a clutch released. So when the 456 piston is released, they keep fluid filled on the spring side of the 456 piston. And this keeps that fluid in there. It basically seals that off. And it addresses any centrifugal force that occurs when this clutch is released. Remember, if we have trapped fluid between the housing and the 456 piston, and this housing spinning, centrifugal force could move that fluid out to the outer diameter and apply a force on this piston. We don't want that to happen because that could drag a clutch on. So what they do is they have this compensator piston here, and they have it filled with fluid. So if there's fluid on the apply side of the 456 piston and there's fluid on the spring side of the 456 piston, they balance each other out and it won't drag that clutch on. So now I got my retaining ring back on. This piston is assembled. Now I can go ahead and build the clutch assembly back up. Start with my wave, steel, friction, and then alternate that all the way up. The 456 clutch assembly is adjustable, meaning I can change the end play on it, and they have you change it by changing the thickness of the snap ring. And this one is 80 thousandths of an inch. 80 thousandths is the mid-size ring. There's like one around 65 or so, and then there's one at I ride on 95 or 100 thousandths. So if our clutch pack clearance isn't correct, I can adjust that. So I'm going from 10 to 80, so I get about 70 thousandths clutch pack clearance. The spec is between 50 and 74 thousandths, so I'm right at the high end of the spec. I am reusing my clutches here, but if these were new clutches, new steels and all that, and I still got that measurement, I'd probably go ahead and put a thicker snap ring in there just to tighten this clearance up a little bit. So I'll go ahead and put my 456 clutch housing assembly in there. I got my Torrington bearing on top of that hub assembly, so that's good. That dropped right in place. Now I can actually go through and put my planetary gear set in there. I want to make sure I have my Torrington bearing in place, and I can go ahead and put the planetary gear set. This is the gear set that splines to that 35R 1234 clutch housing, and then I have my sun gear assembly. So now let's move on to that 35R 1234 clutch housing. This clutch housing has a set of issues of its own. It has a tendency of breaking this weld right here, and it's a fine line crack, and you have a hard time seeing it when you just by the naked eye. So we'll pressure test that and see if there's any bubbles or air leakage or anything like that coming out of there. And also on the inside, the piston that's in here, one of the pistons has a tendency of cracking. So if you ever pull one of these transmissions apart and the clutches in here are burnt up, you're probably going to find either a cracked piston or a cracked housing right here, or both. And some people actually go through and just re-weld this. They'll use a TIG welder and they'll go through and re-weld this all the way around. They'll do that even if it's not broken. They'll do it more as a preventative measure. Okay, let's dive into this 35R clutch housing. And these clutch housings, as we mentioned, they are known to have some issues. They have a tendency of breaking right here on this weld. And right behind this is the piston for the 35R. So if the 35R is burnt up in this, there's a good chance that that weld is broken. Scott makes this tool. It's not this one. I made this one myself. I got a lathe, and a chunk of steel laying around, so I made it myself. But he makes these tools that slide in there and seal off these passageways, so that way you can go in and air test these different sections of this. You can air test the 35R piston and the 1234 piston, and you can even air check those compensator pistons or balance pistons. And his is better than mine. I made mine, I just kind of measured it out, and these are actual 41 TE O-rings that seal off, the red ones that seal off in the input drum. And this was off of an AOD, I don't remember which O-ring it was. I have to, before installing this, we have to go through and push this bushing out. And I don't know if Scott's requires this, but this O-ring seals off in the housing, so I actually need to push that out. I'm going to go over to the arbor press and push this out real quick so that way we can install this tool. Remember, the purpose of doing this is to see if this housing's cracked or if the piston's cracked. We'll be able to get a nice tight seal on here, so when we air check it, we can either visually see if we're getting any bubbles or anything like that kind of occurring around this weld, or we can just listen for some leaks. So really this tool is here just to check these drums to see if they're okay and to see if the piston's okay. Now that I got that bushing pressed out, I can go ahead and install my tool in here. So if you have a lathe, you can obviously make this yourself, but I don't think it's very expensive. The tool Scott makes, I'm not certain, $100 or something like that. So if you are rebuilding these things frequently, which there's millions of them out there, so I figure you will, you definitely want to get this tool. This is not a special tool from GM. This is a tool that some individuals are making. So this hole right here is going to check my 1, 2, 3, 4 piston. Nice tight seal. This one right here is going to check my 3.5R piston. And you hear a leak, but they got a bleed hole right here, tiny little bleed hole right in the drum. So you have to put your finger over it. So it's a good seal. This will check the balance piston on the 1, 2, 3, 4. That also has a good seal. I'm pretty sure Scott's tool seals off. Maybe you have to take this bearing out, I'm not certain. But he's got 4 holes in his, so I know he's checking also the balance piston or the compensator piston for the 3.5R. I don't have that, so I've got 3 out of the 4. That's not too bad, right? So this actually air tested well. If I did this when I was disassembling it and I had transmission fluid in it and this is cracked, I'd see it bubbling up around here, and I know that's bad. So this tool here is definitely worth its purchase price. It could save a comeback by using something like that. We'll go ahead and take the clutch pack assembly apart. Whoa. This first clutch assembly is the 3.5R. I've got 4 frictions, 4 steels, and a wave plate. There's also that 3.5R ply ring. We've seen that before. It's a special tool I use to install that 2.6 diaphragm spring. Well, this isn't the special tool. This is the one that goes in it, but you can make this into a special tool. So here you need to take note, there is no snap ring groove in this portion for that snap ring. So this is where the opening of the snap ring has to go when you're reassembling it. And here's the clutch assembly for it. You can see I've got 5 frictions, 5 steels, and a wave plate. Next I have to compress this balance piston down for the 1, 2, 3, 4 piston to get the snap ring out. So I'll use my screw press. Does not have much spring force on it, so it's easy to spread open. So we'll just tip it over, and you can get that balance piston out and the diaphragm spring. Put it off to the side. I'm going to slam this thing on the tabletop so I can get this piston to come out. You could put the tool back in and use air pressure, but I like making noise. Loud. The TransGo kit instructions do a good job of having you look to see if there's any cracks. Obviously the TransGo kit is mainly a valve body kit, but they include some other pieces of information to help you with a successful rebuild, and they want you to look in this area right here to see if this piston has a crack. So apparently they're finding quite a few cracks in that piston assembly. So next we need to get the piston housing out of here. This is the 1, 2, 3, 4 clutch piston housing, and then the 3.5R piston is around the outside edge there. So there is a little spring, there's another diaphragm spring underneath this, so I'll use my screw press to compress this down enough to get that snap ring out that's retaining all that. To prevent damaging, when you pull that snap ring out or when you go to install it, to prevent damaging the O-ring that's in there, you'll want to remove this 3.5R inner D-ring seal that they have in there. Otherwise you'll be skipping your snap ring over that and the edges of it might cut it. So this seal right here, it's probably a good idea to take that out while you're working with this snap ring that retains this 3.5R and this 1, 2, 3, 4 clutch housing. Because if you're like me, it'll pop off about 5 times before you get it out. And you don't want that to dang it. You won't want it to damage your O-ring. That was easy. So at this point I'll go ahead and pop this piston housing out of there. Slam it back down on the bench. The 3.5R piston and the 1, 2, 3, 4 piston housing. See that separates. I got my diaphragm spring, my pistons. I got my piston housing, diaphragm spring, and the 3/5R piston. You'll also want to inspect this assembly for cracks. In the TransGo kit instructions, they kind of point you to look at this area right here to look for any kind of cracking that might occur. So once we have it completely disassembled, we've cleaned everything up, inspected all these drums, looked at the pistons for cracks, we've gone through and changed our seals. These seals that obviously come in a seal kit. They're D-shaped seals, so they're rounded like an O-ring on the outside, and they're squared off on the inside. They actually have kind of like a V-notch groove cut on the inside there. So we're going to go ahead and put this thing back together. First, what we'll do is, obviously once we've changed all of our seals, we're going to go ahead and put our diaphragm spring in there. We're going to assemble these two halves together. Make sure that the seals are installed. Have it lubricated with TransGel or some kind of assembly lube, or at least transmission fluid. Same thing with the inside here. Now, don't forget there is a seal on the inside of this drum. This O-ring seal right here. We want to make sure we change it. You're best off leaving out this D-ring until you get your snap ring in place so you don't tear it up. So we're going to go ahead and drop this back in. And you will have to work that back and forth because these D-ring seals, as you might imagine, since they're not lip seals, they're designed to kind of compress into place. So there's going to be a bit of force needed to get these to slide down in there. If you're not heavy like me, you might need to get a couple hammer handles or something like that to kind of tap that down in there. So we're going to use our press to go ahead and push this back together. I'm going to lay my snap ring in there. I'll get it down as far as I can get it down without it going into the snap ring groove. I do need to use the press to press this piston down to overcome the tension of that diaphragm spring. So I got my snap ring down as far as it'll go for now. And then I'll use my screw press to push it in the rest of the way. We don't have to go down very far with this piston. Matter of fact, it won't let you go down very far. We're basically just putting a little compression on that diaphragm spring. Once it stops wanting to go down, don't force it any further because it's down as far as it can go. And then at that point, we just need to put our snap ring in there. Now that snap ring's down the groove, that piston return spring is keeping that 3/5R piston returned. Now I can go ahead and put my D-seal in there, and I won't have to worry about tearing it up while I'm trying to install that. I don't know if it can do it, but make sure you don't accidentally roll that seal over when you're installing it. It should have that D shape, that rounded shape facing out. So at this point, I'm going to go ahead and install my 1, 2, 3, 4 piston. I've inspected for cracks. Everything should look good. All right, so that piston's installed. I can go ahead and put in my diaphragm spring. And I can go ahead and put in my balance piston. I think they call it an oil dam, spring retainer, something along those lines. I like to get it started so that way I know when I compress this down in the screw press that it's going to be, that the lip seal is not going to hang up and tear off or anything like that. Once again, we only compress it enough to get the snap ring in. There's no sense of going in further than that. And there is not much tension on this at all, so I don't need much force. Okay, at this point I've got my pistons installed. Now I wouldn't want to air check it yet because there's nothing for these pistons to work up against. So I'll go ahead and install my clutches. I find the part of the spline that's missing, the snap ring groove, and I kind of split the difference there on that. There's the wave plate, steel, friction. So this snap ring measures out to be 115 thousandths. I just need to make sure I position that snap ring where the groove isn't cut in this housing. This clutch pack is supposed to have between 60 and 78 thousandths of clearance. So before I assemble my 3/5R, I'm going to go ahead and measure that, see if that's what I'm getting. So we'll go ahead and check our clutch pack clearance. So pushing down on it a little bit with a little bit of force, I can get to go close to 0. And lifting up on it, I'm going just under 70 thousandths. The spec on this clutch is 60 to 78 thousandths, so we're within. This clutch pack is adjustable. There's 3 different thickness snap rings that we could put in there. I already have the thickest snap ring in there, so we really can't tighten this clutch pack up anymore. We're going to go ahead and install my 3/5R apply ring. These ends right here, they fit into a groove machined around in the 3/5R piston. So they fit In between this gap that I've created between my 1, 2, 3, 4 clutches, or the steel plates really, then the ends of those fingers fit inside that 3.5R piston. Where Sonex offers a heavy-duty version of this plate, because you can see it's just a stamped steel plate. So here I'm going to go ahead and put my wave plate on first. That lays up against that ply ring. Then I'll alternate my steel, friction steel up to the top. My top snap ring thickness is a little over 80 thousandths of an inch, 80 to 85 thousandths of an inch thick. So pushing down on the clutch assembly, I can get to 0. Lifting up, I get to about 55 thousandths. So remember that you'd put a 10-pound weight on these things, but you can simulate that and kind of get an idea how much it's going to deflect. If I push down on this, I see it moves about 10 thousandths, maybe 15. It's between 50 and 60 thousandths, and the spec is between 48 and 70 thousandths, so it's well within spec. The snap ring that we have in here is the middle size snap ring out of 5 available snap rings, so we'd have room for adjustment if we had to go either direction with it. Okay, I'm going to go ahead and air test this again using my special tool, and assuming everything air checks okay, then I know I can go back together with that bushing and install it into the transmission. This is the 3.5R. This is the 1, 2, 3, 4. Pretty good seal. At this point, I'll remove the tool, reinstall the bushing, and then I'll be able to install this 3.5R 1, 2, 3, 4 drum back into the transmission. Now I'll install this drum into the transmission. There is a special tool that I'm going to do without. A lot of people make these, I just haven't gotten around to making one yet. It's a band that wraps around the outside of this, and it has something to grab onto on this side and kind of like a vice grip on that side. So that way when you lay it in there, you can clamp that on, and you have to wiggle this drum back and forth to get all those clutches to line up around these 2 drums. I have to line up my 3.5R around this outer set, and I have to line up my 1, 2, 3, 4 around this inner set. So there's 9 clutch discs that we have to line up on the way down there. And it's easy to get your finger pinched right down in here when you're trying to rotate this by hand, so be careful. And you also have to get the 3.5R drum to slide into that front planetary gear set. So how do I know when I have that drum assembly all the way down? Well, I can measure from this thrust washer surface here down to the bell housing. From the thrust washer to the bell housing, about 1 inch, 660 thousandths. With the additional 700 thousandths of the thickness of this bar from this thrust washer down, it's 1 inch, 660 thousandths of an inch. And if I use this bar laying across the bell housing surface where it bolts up to and measure down to the surface where that 3.5R contacts, it should be a little deeper. It should be a little bit more clearance. The difference of that will be the clearance between this 3.5R drum and the thrust washer that we have on this pump. So it looks like I've got this all the way down. We're going to go ahead and move over to this oil pump assembly. This oil pump assembly is an area of common concern with these transmissions. As I mentioned earlier, these transmissions have a tendency where the torque converter clutch breaks and the fluid coming back from the torque converter gets diverted through the pump on its way back to the cooler and then the lube circuit. So if a torque converter fails, it takes out this oil pump. And there are a lot of things that people do to address that. Some shops actually will go through and remachine these parts and renew them. Some will go out and just buy new bell housings because that makes up half of the pump assembly. So we're going to go ahead and take this apart and see what kind of condition this pump is in. Now the service manual tells you to leave this stator support alone. They don't want you to take these bolts out. They say doing so will ruin the transmission. But there, as you can obviously see here, there's a gasket underneath this. So, I mean, it wouldn't be a good idea to not go through and change this out. So I know in the field, pretty much everybody takes this stator support out so that they can change this gasket. And now for the big reveal. This pump half here looks great. There's no scoring at all. As you can see, half of the oil pump exists in the bell housing, so this is where people run into a little bit of an issue. If there is metal that passes through this oil pump and ends up tearing up not only the stator half, but also tears up the bell housing half. So some people go through and just purchase a new bell housing. And if they're available, you know, sometimes you can find them on Amazon fairly cheap. And some techs will go through, and if they have the equipment, they'll go through and remachine this pump half. So obviously we've seen this pump design before. This is the pump rotor in the middle. These are the vanes that go around. These are little guide rings right here to kind of keep the vanes pushed out. And when the torque converter, through the lugs of the torque converter, when the engine starts, they're going to drive this pump. And it's going to create a suction on this side, carry that fluid over, and compress it out on the other side. And when the transmission is satisfied with the amount of pressure it's got, the pressure regulator valve is going to move into a position where it is going to enter fluid pressure into this passageway right here, basically between this pivot pin and then this Teflon seal. And what that's going to do is that's going to pivot this pump, and it's got a pretty hefty spring. Let me just go ahead and pull that, let me just go ahead and pull that spring out. So what pressure on this side of the pump's going to do is it's going to pivot that outer slide. And when they pivot that slide, it's going to change the amount of space that I have around this pump rotor. And you can see here, this would be operating in like a maximum displacement. So when this is rotating, it's creating a great suction, carrying that fluid around and squeezing it out on the other side. And then when they reduce the output of the pump and they shift that slide over, they've equalized some of that space around there. And now it can't create as much of a suction, so it means it can't pull in as much fluid, and then it has nothing to compress. The compression area gets smaller. So they can basically change the expansion and compression areas of this pump by altering the fluid between this pivot pin and that Teflon seal. And it's the job of the pressure regulator to control the pressure that's in this passage right here. So once pressure is satisfied, the valve moves to a position where it opens up this passage, and that's called decrease, and it'll lower the output of the pump, and it'll lower it however far it needs to control the output pressure of this oil pump. We're going to look at this pressure regulator valve lineup in this oil pump because this is an area that wears out pretty badly, and TransGo and Sonex, they've got fixes for this. So if this bore is worn out, we can address it either with the TransGo or the Sonex kit. We'll look at that a little bit later. So let's first take this apart, inspect the rest of the oil pump, take my pump guide rings off, the little spacer there, plastic washer. I'll pull my vanes out. That sounds painful. Pump vanes, not body vanes. Could be pump body vanes though, but sealing off between the edge of the pump slide, they give you a little cut of O-ring basically to work like a spring, and then a little piece of Teflon seal. So those pieces are going to ride up against this pump slide. Those seals live in that spot there, and they make a seal between the pump slide and the bell housing. And underneath it, we have this big Teflon seal, and then kind of like that side Teflon piece, there's a O-ring that kind of also works as a spring, if you will, to keep this Teflon seal into contact with this bell housing. And then we also have our pivot pin. Looks like they've attached this spring so it's not as easy to lose, because that little guy can roll pretty far and it's so small, it's easy to lose. All right, so we'll put those aside. This pump, as I mentioned before, is in great shape. There's no scoring at all. If you had an issue with this where it was scored up, there was metal that went through here and tore up this pump surface, some people go through and remachine this pump. And of course this side here is, if it's scored up, people will chuck it in the lathe and machine it out perfectly flat. Or they go through and just buy new parts. But you could save a lot of money by machining these things. There are a couple people out there. I think Scott Hetrick, he machines these bell housings. Richard Worrell, there's a few of them out there that do it in their shops. So one thing, if you get these machined or you buy any new parts, a new slide, a new rotor, a new bell housing, one of the most important things that you're going to have to look at is to ensure that these parts have freedom of movement when you bolt them together. There's a specific end plate specification that exists between this slide, this rotor, and the half where the stator half bolts up to. It's like 1 to 2 thousandths of an inch of end play. Basically, the slop that the rotor has can only be about 1/1000th, and the same thing with the slide. So how would you measure that? The easiest thing to do would probably put a piece of plastic gauge across this, and then just lightly bolt those halves together, take it apart, look to see how much it squeezed it. You could also use a depth mic. So if you had a real depth mic, measure down the depth, measure the thickness of the rotor and the thickness of the slide. The depth has to be about 1 to 2 thousandths more than the thickness of the slide or the thickness of the rotor. That's probably something that you really want to check no matter if you buy a new bell housing or if you buy a one that was been machined, or if you're machining yourself. Just make sure that you're getting your 1 to 2 thousandths clearance. And like I said, the quick and easy would be laying some plastic gauge across there, bolt it up, take it back apart, look to see if you've got your 1 to 2 thousandths. I mean, that's a typical thickness plastic gauge that we would have for engine. So we're going to go and put this back together. Obviously, our overhaul kit is going to include things like our Teflon seals and O-rings. You'll have to buy pump vanes and guide rings if you need those. When I put this together, I leave the pivot pin out for a second so that way I can go back in with my O-ring and Teflon seal. And then I can pull that over with my hand, and then I can slide in my pivot pin. That seems to be the easy way to do it. Ideally, you would try to find the smallest pair of channel locks that you own to do this with, just like I did. Try not to nick anything up on your way in. If you feel like you might have contacted something a little too firmly, you might run a little flat file across it to knock any burrs off. I'll go back together with my pump rotor. Don't forget the little plastic ring that goes in there. If you're reusing the pump vanes, make sure the surface that's worn all the way across is facing out towards the pump slide. On the inside, you'll see it's only worn on the ends because that's where the vane rings come into contact. So you don't want that end facing out, because if you have any real wear on the outside where you can actually feel it with the fingernail or just really just visually, that might introduce pump noise, or it might introduce a pressure issue. So I'm going to go ahead and put the shiny side facing out towards the pump slide. So I have this ready with my O-ring seal there. One thing that's interesting to note, really doesn't have anything to do with diagnostics, is if you stare at this oil pump, you could see that from the factory they designed these pumps to minimize noise through their design. If you look, these vanes are closer together, and then they get wider apart, and then they get closer, and then they get wider. So it's almost random on how they place those vanes. And they do that so that you don't get into like a resonant frequency of pump pulses that hits a certain frequency. If these were all exactly the same distance apart, it would have a kind of a, at certain RPMs, it would create a frequency that might cause a vibration somewhere or a noise issue in the vehicle. So by mixing up the distances between these pump vanes, they don't really create a constant frequency as this pump is spinning. So you'll see that on cooling fans too, like the electric cooling fans or the mechanical cooling fans on an engine. In case you've never noticed that, I thought that was something interesting. It's worth mentioning. So we're going to go ahead and push this off to the side, and we're going to move over to our stator half of the oil pump. We're going to go ahead and pull this pump stator support out. And I've already taken those bolts out, so there is an interference fit here so it won't just fall apart. And call me old-fashioned, but I don't like to beat on things, especially when, like this pump here, doesn't have a gasket that goes between the two pump halves. So I want to make sure that this stays true and not warped. And so I've got my little homemade tool here. I could put this in the arbor press, lay a plate across this, push down, so I push evenly off of these flat surfaces. And I do it as close as I can to the center of the stator. So that way I'm trying to minimize any warpage that I might create. It doesn't take a lot of force. They do give you that gasket in the kit, so you might as well take this apart, so if no other reason but to change this gasket out. I do have my front bushing right here that supports the input shaft where it comes out of the transmission. I got this rear bushing where it supports the input shaft where it goes into the 35R 1234 clutch housing. These sealing rings, they do come in the kit. One thing that you don't want to forget is that there is an O-ring seal that lives under there. It'd probably be worse if you took it out and then forgot about it and never put a new one in than it would be if you didn't realize it was even in there to begin with. But the O-ring keeps pressure out on these rings. These are non-rotational rings, which is different from the very early design, so this is something they added to it. The non-rotational rings will lug into these notches, and that'll prevent this from spinning, the ring from spinning, so the drum will spin and slide around this surface right here. If it was a rotational design, pressure would go underneath that seal, push the ring up against the surface, and the ring would spin within the stator groove and stay kind of connected to, if you will, or at least pressured up against the 3-power clutch housing. But they don't want that in this. They use the non-rotational design so that the drum spins around a stationary seal. So you'd want to go through and change your rings and the O-rings behind those for each of those. So some of these earlier units, these 6L80s, they have these rotational rings. And you saw on this transmission that it had non-rotational rings. And with the rotational rings, when pressure gets in between these passages to apply clutch, pressure gets behind those rings, pushes those rings out, and they grab onto the drum and they spin with the drum. So the non-rotational rings, obviously, since they're notched in here, pressure can get behind them, but basically the outside of the ring and the drum make the seal. They changed this design from the rotational ring to the non-rotational ring because they had cross leakage issue. TransGo in their 6L80 valve body kit includes these rings that, as you can see, get kind of tangled up here, but and they have a new Teflon seal, scarf cut, as opposed to these plastic type that has like a notch cut in it. So they got the Teflon seals with a scarf cut. And then they also have these expander rings. And these expander rings go in the groove first. I'm just going to do this top one because this is a lab unit. But you lay this expander ring down in there. And the key is to make sure that these little pieces of wire don't overlap each other when they're in there. You don't want the wires to cross. You want it just to lay in there like a nice spiral. Because if they cross, it's going to hold that Teflon seal out further than it should. Once that expander ring's in there, you could take a little bit of TransGel, put it inside this groove that we've got. So you can take your new Teflon seal, and remember that the scarf cut has to kind of match up there. You don't want them overlapping the wrong way. This is how it's supposed to go. You don't want it to go that way. And then just make sure your scarves kind of match up and you have them pushed in there with your against that TransGel. You do that on all three. Now you've dealt with the cross leak issues without having to replace the stator. Now I'm going to look at my pump. There are some modifications that we're going to do to this pump, but we'll go ahead and take this completely apart first. Get out of there. There we go. There's a pressure regulator valve. You cannot get to these valves without pulling the transmission out, unfortunately. Okay, I got my pump pulled apart, so we're going to go through and clean all these pieces off. And I'm going to go ahead and reassemble it just so I can do a vacuum test on these to see if they fail a vacuum test or if they're within spec. Now we're going to go ahead and vacuum test this pump body. Sonex has you pull out the AFL valve from the valve body to temporarily place in the place of the converter feed limit. And the reason why is because this converter feed limit, it operates like a normal pressure regulator where it's got a hole at the end of it that kind of opens up into this passageway right there. So obviously if we vacuum checked this section right there, it'll leak right out through that passage and feed into this. So I'm going to go ahead and try it two different ways. I'll go ahead and put the AFL valve in there like they recommend, but I'm also going to go ahead and put a piece of electrical tape around that and see if it seals up, so that way if you didn't want to pull your AFL valve out just to do this test. And obviously you would have to remember to take that electrical tape off if it works. If not, you can always just use the AFL valve. So I'll put the AFL valve in there for now. This port right here is going to check the pressure regulator valve, and I have to cover these two passages. And then this right here is going to check the boost valve, the pressure regulator boost valve circuit. And I have to cover both of those circuits here, the little pinhole there, and then the area where pressure feeds into from the pressure control solenoid. Okay, the first thing I'm going to do is calibrate my vacuum pump. With the orifice in there, I'm supposed to get between 5 inches. And then if I plug it off, it should go up to 25. So 25 and 5. Now I take the calibrating orifice out and go ahead and put my nozzle in there. I have to hold that valve in a position so I have to hold it so that that valve is in contact with both lands on either side of this opening. Then when I put vacuum on it, you can feel it tugging on it. I'm getting about 21 inches of vacuum. So that seals off pretty good. Now on the balance end of this pressure regulator valve, I'm supposed to make sure I cover both of those sections right there. That's measuring out at 23 inches of vacuum, so it's strong. Then on the boost valve end, I'm supposed to make sure I cover the pinhole and also the boost valve. And I'm getting about 20 inches of vacuum on it. As I promised, I'll go ahead and do the converter feed limit with the original valve, but I've got electrical tape wrapped around that orifice. Kind of like with the AFL valve, I have to hold it in a position to make sure it's blocking off the land. 24 inches. That's a really good seal. As far as this core is concerned, this pump is in great condition. There's really no wear where the pump halves are in the bell housing or in the stator support half. The pump bores are in great condition. There's no excessive wear. That's a really good sign. I don't think we needed to use the AFL valve to test it, as long as we put electrical tape over that little hole, so that way we can accurately vacuum test that section. Just remember, when you're vacuum testing this section, you actually have to hold this valve back. You have to put this valve land right over that passageway right there, because you're just basically checking to see if that part of the bore is worn out. And this one's in good shape. And I can go ahead and, I got my AFL valve still in there. Probably won't want to leave that in there. Don't think it'd work right. Now as far as this pressure regulator valve is concerned, I think I would go ahead and install an upgraded valve in there. The aftermarket's made better valves for this pump. So I think this is something you want to do on a rebuild, just to make sure that your unit lasts out there. So here I have the original pressure regulator valve lineup. The original valve is made out of aluminum, and they see a lot of wear on these lands right here. I mean, this pump looks great. Some of these transmissions that have miles on them, they just seem to wear it out bad. You can see the TransGo valve is a lot different. It's got this elongated portion here and that elongated portion there, and those are going to ride in areas of this pump body that did not see any wear ever. They're like virgin metal. And then they're going to replace, to work with it, they've got this little spring seat that'll kind of double as that surface on the OE valve, and they replace their spring. You still use a small bumper spring, but they replace their the original spring with their red spring. And then they put in a steel boost valve assembly, and that replaces the original aluminum boost valve assembly. And built into this boost valve assembly, they add a pressure relief, so that if pressures ever spike, and they have figured that pressures have a tendency of spiking, that's what causes damage in these transmissions. If the AFL pressure ever spikes and that passes through the pressure control solenoid and finds its way here at the boost area of the pressure regulator valve, this is a relief valve. It's going to blow off that excess pressure so you don't over pressurize the transmission and cause failure. So this is a really nice modification. Once again, even if I had a pump that really didn't have any excessive wear, why wouldn't you install a valve like this? Because you're dealing with an issue that's going to happen later on down the road. So it's a great setup to go through and put this in, and you're making the final product better than it was originally. The parts that you're not going to use are the original pressure regulator valve, the original pressure regulator spring, the boost valve, the original boost valve, and its sleeve. So those parts do not get reused. About the only things that you're reusing is their little bumper spring, and then also the pin that holds this assembly together. And I'm going to go ahead and assemble my boost valve before I install it. This is the check ball and the spring, the relief valve spring. Don't let that spring shoot out, fly across the shop, you probably never find it. Now we got the TransGo valve installed, and now we've addressed any future wear that could have occurred in this pump body. At this point, I need to put my stator support back on. I'll go ahead and check this for flatness, replace my O-ring seal that I've got in here, and also put a fresh gasket on there. Now we're at the point where we're going to go ahead and bolt this down. Now there are no torque specs for the stator support because, remember, GM doesn't want you taking it apart. So I guess we'll have to do our best guess. I would start with those just because usually you want to tighten things from the middle out when you're assembling. Go in a little star pattern. GM says if you take it out, you'll damage the transmission because of center lines and whatnot, but I have a hard time believing that because they've got a dowel pin right there, and it is an interference fit. So I don't see how the center line can get thrown off by you messing with this. I'll go ahead and do a final torque on it once I'm all together with it. Now there is a dowel pin that holds the pump half onto the bell housing, but you can see there's still movement there. There is a pump alignment tool that goes around there and kind of keeps it centered. I like living life on the edge, so I'll probably just go ahead and eyeball it. You can feel the edge of that pump, and it should be sitting flush. The edge of the stator support half and the edge of the bell housing half should be flush. So if you run your finger around it and there's a step at all, then you've got it off-centered. If it feels pretty good, just kind of lightly snug down a couple of them. Check it again. It won't be able to move once you lightly snug down a couple of these. That feels even all the way around to me. So these pump bolts only get tightened down to about 100 inch-pounds. So that's what I'm going to go ahead and tighten these stator support bolts down to as well. And then here's the torque sequence for the pump body to the bell housing. First 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and lucky 13. So our pump's assembled, we got our O-ring on there, our thrust washer is in place, we got our sealing rings with the O-rings underneath it, new bushings if they needed them, filter seal is installed, this thing's ready to go in. Okay, it's a good idea to snug down just a couple bolts, and then make sure you have the ability to turn the input shaft. That way if something's bound up, you're not crushing anything. And if everything's good, do your little star pattern and tighten the rest of the bell housing bolts. And so at this point, I can also air test the transmission through these exposed passageways. So that way we can make sure our sealing rings are doing their job and everything's good from the pump back. And this first passage right up here is the 1, 2, 3, 4 clutch. That's a good seal. This next passage over here is the 3/5R clutch. You can hear that's got a pretty good seal. This down there is my 4/5/6. Some of these other passages are going to be the balance pistons. And I'm air checking this with about 50 psi of air pressure. I'm not putting much in there. Now right through here, where the valve body is going to connect through the bridge seal to that center support, I've got the 2/6 clutch right here. I'll see it move. Then right next to it, I got my low reverse. And you can see its piston move. At the opposite end here, I've got the other low reverse area. We're going to go ahead and go through this valve body now, and while we're going through the valve body, we're going to go ahead and install these TransGo kits. Part of this kit we already installed in the pump with the pressure regulator valve, and this kit right here is going to be kind of a supplement to that. It's got some clutch select valves and also the torque converter clutch regulator valve. So between these two kits, they address the pressure issues and the torque converter clutch issues. So we definitely want to put these in. Good idea to put those in whether the transmission really needs it or not. It's good insurance. So this is the Tecum, and it has all the solenoids in them. Unfortunately, we cannot split this apart to get to the solenoids. They're in this pre-packaged plastic assembly here that if you try to get anything apart, you destroy it all. So if anything goes wrong in this, you pretty much have to replace the whole kit and caboodle. The TransGo kit gives you a nice little piece of information here. They identify, for the upper valve body, they identify these, what these 4 different letter designations mean. And they're for this different size transmission. So if you've got some of these valve bodies sitting out as cores or whatever and can't remember what it came out of, it identifies that. It's like A is a 6L45, B is a 6L50, C is a 6L80 and D is a 6L90. So that's kind of nice. Little piece of information there to help you identify what these valve bodies came out of. So I've got all these valve body bolts taken out. I'm going to flip this over and lift this top plate off the lower valve body. And there are check balls. That's the reason why I flipped it over, because there's check balls underneath this plate. These plastic check balls, there should be 7 of them. We got 1, 2, 3, 4, 5, 6, 7. They're plastic and clear. And this is something that comes in the kits, and you definitely want to change these out. Matter of fact, you might want to take the old one and measure them and see if they're still round, because they found some issues where the check balls end up kind of becoming out of round, maybe resulting in the failure or the symptom that you have in the transmission. Can't use a magnet to get these out. Next, we're going to take the valves out of these valve body halves, clean it up, do a vacuum check to see if any of these bores are worn out. There's only 4 valves in this, so I'll go ahead and pull them out too. I got my valve bodies all gutted, so now I'm going to go ahead and clean these out, get the oil out. Brake clean my valves and my springs here, and I'll reassemble it and do a vacuum check and see how these things turn out. Let's go through and identify some of these valves. This valve right here is the actuator feed limit valve. This valve here is the first and reverse and 456 clutch regulator valve. This next one down is the first and reverse and 456 clutch boost valve. Next we have the 2.6 clutch regulator valve, and this is the 3.5R clutch boost valve, and this is the 3.5R clutch regulator valve. This is the 1, 2, 3, 4 clutch shuttle valve, and this is the 1, 2, 3, 4 clutch boost valve. In the other half of the valve body, we got our clutch select valve 3 and our clutch select valve 2. This, of course, is our manual valve. This is the compensator feed regulator valve, and this is the torque converter clutch regulator valve. So let's go ahead and put this back together, and then we'll vacuum test it. All right, so my lower valve body is assembled. There we go. We got the upper and lower valve bodies assembled. I'm going to head over to our vacuum test station, and we're going to see how well these bores seal up. So on this TCC regulated apply valve, you need to put in an 1/8 inch spacer there between the TCC valve and the shuttle valve. Put your end plug in there, and then your retainer. That makes sure the valve is living in the proper position, so that way when we vacuum check it, the valve is where it needs to be. I went ahead and circled some of these passageways. Over here we're going to be doing these 3 passageways for the torque converter clutch regulator valve. We're going to be doing this passage right here for the compensator feed valve. On the other end of the valve body, these are the 2 clutch select valves, and we'll check basically the ends of those valves. We'll verify the calibration on my tool. 5. I knew I bumped that. 5 and 25. "24 inches, 20 inches, 23 inches, compensator feed, 23 inches, clutch select, 23, 23, 21 and a half, 22. This half of the valve body checks out pretty good. I don't want to forget to take out this 1/8 inch thick spacer. We got lots of places to check on this upper valve body. There are some sections here that I'll have to plug the other side. First one right here is the 1, 2, 3, 4 boost valve. 20 inches. The other end of the boost valve. Got 19 inches. This is the 1, 2, 3, 4 clutch regulator and shuttle valve. 23 inches. 22 inches. This is the 3.5R regulator valve. 21 inches. 19 inches. 20 inches. For some reason they say you need to have their vacuum test plate for that one. I don't really know why. This is a 3.5R boost valve. 19 inches. Have to put your finger on the other side of the valve body for that one. And I'm getting 18 inches. This next one is the 2.6 clutch regulator valve. Low, that's 15. 22. 17. This is the 4.5/6 clutch boost valve. Have to put my finger on the other side for it too. Again, 18. 19. And at the end here I got my 4.5/6 regulator valve. Got 23. And 21. Lastly here I got my AFL valve. 23 inches. The only one that tested lower than the majority of them was this end of the 2.6 regulator valve circuit here. I'm going to talk about the TransGo shift kit that we're installing. We're actually installing two kits. The SK6L80, which we've already installed part of that. That was the pressure regulator and the boost valve. We did that in the oil pump. But it also includes a new actuator feed limit valve that we're going to install in the valve body. And the second kit here is a 6L8 CS-TCC, and it works on the 6L45, 6L50, 6L80, 6L90, 2007 to 2016. And what it's going to include are these clutch select valves, these clutch select springs, and it's also going to include a torque converter clutch regulator valve assembly, kind of updated system. So let's go take a closer look at that. Now looking at these clutch select valves, other than the fact that they're made out of steel, they really don't appear to be any different than the original design. Now in the instructions, they inform you when you go to put these in, these go in the lower valve body. They say set it upright, kind of like this, and when you drop the valve in, it should bounce. And it does, bounces pretty good. Got good hops. Whoa. And if they don't do that, if it doesn't bounce and it has a kind of a tight spot in there, what they want you to do is take a little screwdriver, well, not a little screwdriver, but go between the valve and the land and tap this with a wrench. I think they say a 5/8 wrench. And I'm sure what you're doing is you're finding the burr or the rough spot and you're kind of embedding that into the aluminum. So you're doing that all the way around or in the spot that you suspect is tight, and that's going to try to free up that valve. And you're not supposed to finally assemble this until you know you can. Drop that and it'll bounce. Another thing with this clutch select valve is that they have you look at the bonded spacer plate. They want you to look in this area right here, and if it has that little key shape or whatever you want to call it, the slit, that is going to be an indication that you need to use their supplied springs. If it does not have the slit in the gasket, then you're supposed to use the springs that originated in this valve body. Otherwise, you're going to use the original springs. Pretty simple. Just got to read the instructions, right? Yeah. That's a good catch, wasn't it? The other valve that's in that CS-TCC kit is going to be the torque converter clutch regulator valve. And you can see how they changed that. They elongated this spool right here, So this is longer on the replacement valve than it is on the original one. And so this area is going to ride in an unworn section of the valve body bore. They also changed the spring. So they got the spring in a pocket there. And it's a different spring. And talking with TransGo, they do that on purpose because they get finer control out of this valve with the different spring rates. They want you to reuse the shuttle valve and then the end plug and then the retaining clip. So we'll go ahead and put this in. Okay, so this lower valve body is done now. That was easy. Now with the upper valve body, the only valve that we replace is the actuator feed limit valve that lives in this bore right there. And what they're going to have you do is replace it with this kind of newly designed valve. This is the original one with the original spring and the original retainer. We actually get rid of all three of those. And this valve right here is designed to ride in its own little bushing. And if you look close, there's a little feed hole right there. That's where oil can get in to the reaction area of that valve. So since it changes the surface area of that reaction land, we need to change the spring. And then there is also a little spacer to help stabilize that spring and a new clip because there's probably a good chance that this could come out of the original clip if you used it. Maybe get caught or something like that. So they give you a new clip. So let's go ahead and put this back in there. And we'll be able to call this valve body done. All right, there we have it. That was pretty simple. Now I'm sure you're curious how these vacuum test. Obviously this transmission didn't have any bad bores when we checked it, but we should still check this with the replacement valves to see if they're holding just as strong a vacuum. So let's go do that. So this clutch select valve is pulling 21 inches. And on this end it's pulling 23 and a half. On this one we've got 22 inches. And we got 20 inch. On the regulator valve, 24 inches. So just like some of the other GM transmissions, they use these pressure switch films that live inside these spots right here, and they have a tendency of cracking. When they do, they set DTCs, put the transmission in limp, give you all kinds of problems. So in the TransGo kit, they give you these films and these diaphragms. Now, one thing I made was a little special tool. I know Sonex makes a tool that a lot of people really like. I don't have that tool, but I made this. It's really nothing special. Really, you can make it out of a pipe that's about 1/2 inch in diameter, and you drill the inside of it out to about 7/16, and then you kind of cut 2/3 of it away. And what that's going to do is it's going to allow you to get around this pressure switch assembly, because that's the hardest part, is getting this diaphragm in there. This lip right here has to fit underneath this plastic, has to kind of tuck in, and then when you bolt this tecum to the valve body, it seals off on the top and it also squeezes down and pushes down on this pressure film. So that's the trick, is you got to get this thing sitting flat and it's got to be tucked underneath, and that's the hardest part. So this brim right here is the difficult part. But this tool makes it a little bit easy, because once you get it started, you can kind of push down in it. You can kind of push down on it like this and then kind of tuck it in with a screwdriver. So we'll go ahead and give that a go. Just kind of get underneath it. Well, now I definitely have to replace it, don't I? Jeez. There's the original pressure film there. It's not broken. Well, I probably broke it taking it out. But one trick that some techs do is they will take a Sharpie and they'll put a dot right in the middle of these pressure switch films. So that way, once they have it in, because they kind of swim around in there a little bit, if you put a dot in the middle, after you get it in there, you can see if it's centered. You're supposed to bend this like an upside down taco and just kind of slide it in there. This isn't the difficult part. And you can tell by looking at that one that it's not centered. It's off to the side a little bit. It might help to use a eraser of a pencil to kind of keep that in the center. TransGo recommends putting gear lube on this to help it kind of slide in easier. And I recommend Master Pro Synthetic 75W90 for all your diaphragm installation needs. Then we'll try to just kind of work it in there. Chances are you're going to get it mostly in, and then there's going to be a little spot that's not going to want to slide in for you. At least that's my experience. You can use the screwdriver and gingerly try to push it in. If it's not going all the way in, if you peel it back, you can probably tell if it's sliding in under there or not. And that's where this little tool can come into play. If you slide it back and tuck this tool in behind it, kind of wiggle it around, that's going to push the brim of that hat under that plastic. That in conjunction with a little screwdriver and a little bit of patience. All right, that's pretty good. I think I got it. Patience is the key. Maybe help from a little tool. I think if I were to improve on this tool, I'd make it to the point where this end would slide in and I could kind of maybe spin it. So I got a lathe, so if I machine this side down, I could probably make it so this would be like a sizer almost. This will help get it installed, and that one will make sure everything's seated. A little something to do on my spare time. Let's start reassembly by putting our check balls in place. This is an early unit and it uses 7 check balls. So we'll see one here, 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 here. All these bolts are the same. They're all 36 millimeter length bolts. There is a torque sequence. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's the torque and the sequence. So we have a few different length bolts for this half of the valve body. And some of them have 10 millimeter heads. A couple longer ones have 8 millimeter heads. And then a lot of them have 7 millimeter heads. So the bolts that I painted with white, those are 8 millimeter heads, and they're a little longer. Everything that doesn't have paint is a 7 millimeter head, and then these 4 right here, these are 10 millimeter, as well as these 2 back here with Tecum. I didn't paint those, but anyway, we're all bolted up now. We got the mode switch installed, a range sensor. There is a torque sequence. Can do some socket changing here, but we're down to the final stretches now, so we're going to put our bridge seal in, and that goes in this case right here. These are all included in the kit. And the aftermarket does make some solutions for this bridge seal. Sometimes the center support is not locked in there, and it might have some looseness side to side, in which case they drill and they have an insert that locks it in place and has a better seal. You always want to make sure you replace these though, because these seals can potentially blow out on the side, and then you'll lose the pressure to your low reverse and 2/6 clutch. Then we also have these bridge seals towards the front of the valve body. You want to make sure those are installed too. And those are also included in the kit. When you bolt down the valve body, they're going to squeeze up against the surface on the pump there. So when we drop this in, about the only thing we have to line up is our manual valve to this pin. We don't want to forget our pass-through connector. We replaced the O-ring seals on it. And remember, this lever right here is what you lift up on the valve body. You install your pass-through connector, push that lever down, and that locks that in place. Our new filter